All right, let's jump in. So first of all, thank you very much everyone for joining. I'm Yvan Fafchamps, and on behalf of UbiOps, welcome to another live edition of our Conversations with MLOps Thought Leaders. To those of you who joined our last session, it's really great to have you back. I'm looking forward to seeing some more great questions this time around. And to those of you joining for the first time, really happy you can make it. I'll take the opportunity to get you up to speed with the format of this session. So today's theme is going to be how to solve AI scaling challenges. And we're going to be looking at this in the context of medical technology or MedTech, as it's usually called. And during today's chat, we're going to start out by setting the scene, and then we're going to get into the trends, and then some challenges, and then how to tackle those challenges. Once we've covered the subject matter, we're going to open the floor for the Q&A. And don't forget, if you have a question that comes up at any point during the conversation, you can always just send it in via the chat or during in the questions function, and we'll make sure we get to answer it in the latter part of the talk. If you're with me so far, you can always throw a thumbs up in the chat, so I know you're all clear. Otherwise, we're going to get down to business. Nice, I can see those thumbs up coming in. Great. So I have the pleasure of speaking with Leonardo Romor today, who is an AI software engineer at Ellogon.AI. For a bit of background, Ellogon is a Netherlands-based MedTech startup that's applying AI to improve patient selection for cancer immunotherapy. Leonardo Romor's work focuses mainly on building Ellogon's architecture for deploying their AI algorithms successfully in hospitals and in other institutions. Did I get that right, Leo?
That's exactly right. Indeed. Well, I'm Leonardo. My background is in physics and high-performance computing. I completed my master's in artificial intelligence at the University of Amsterdam, and since then I've been working for Ellogon as an AI software engineer, as you said.
Great. Well, it's great to meet you. And so as a senior AI software engineer at Ellogon, what exactly do you do? What does your day-to-day look like?
So my main duty here at Ellogon is to work on the development of the software as a service, which is our main product. And my day-to-day tasks are essentially around scaling AI pipelines, of course, which our product is about. And my day-to-day tasks are about building Docker containers, writing front and back-end code, writing Kubernetes manifests, and of course, designing these pipelines such that they're scalable.
Great. And for those who are unfamiliar, why don't we talk a bit about Ellogon itself? Like, what do you guys do?
Yeah, so Ellogon is a spin-off company of the University of Amsterdam. It was founded by two professors in artificial intelligence and still from the University of Amsterdam. And well, at Ellogon, we focus on the selection of cancer patients for immunotherapy. So as you might know, cancer is the second leading cause of death worldwide. And since 2014, a new therapy called immunotherapy has become available in hospitals as in addition to standard therapies such as chemotherapy. And compared to chemotherapy, it has very nice, I would say features in the sense that it has 3 times better survival rates. And overall, also, you have less side effects in general. And there is, though, one problem with this current treatment is that, but we're going to get to that later. So the main thing is that how immunotherapy works in layman terms is that it helps a patient's own immune system. It gets boosted and such that it can attack cancer cells in a more effective way. But currently, of all the patients that have cancer that are selected for immunotherapy, only 50% of them actually benefits, and the others do not. So, why is that? This is an interesting story in the sense that in the current clinical workflow, the clinical workflow is essentially how hospitals perform this decision. The current clinical workflow goes like this. Well, there is a medical expert that has a case, and what it does to make an informed decision, ask for say a biopsy, or which in this case he would throw a needle, or for a section in case of surgery, and takes a small piece of tumor tissue from the patient. It gets sliced, it gets stained such that it has a purple color, pinky color, like you see on the right side of this slide. And then this is scanned, digitized at a very high resolution, and such that it can be inspected. So what medical experts do is then to look into this tissue at in a very zoomed in and magnified way, and search for characteristics of this tissue that can sort of that inform them that, okay, this patient is having a good immune response. So if we help the immune system to respond even better, he might have some chance to actually get through the disease and survive. But as you might imagine, so these images are huge, right? And when medical experts look at these images, it's really hard for them to exactly quantify these characteristics. They just have to kind of eyeball, because it's a bit like counting how many rooftops would be on Earth by looking from the moon, say, as a comparison. So this leads to high inter-rater variability, which means that if we have 10 medical experts, only 3 of them would agree on whether to administer a treatment or not. Medical experts do that not just by saying, oh, I think it's good or not. They usually try to use a score. And this is what gets used as a threshold. So it's get thresholded, meaning if the score is above, say, 30%, say there are so many lymphocytes, it's above a certain percentage, they say, okay, then we're going to use this treatment or not. So this poor selection has consequences, in the sense that, first of all, it happens that the other 50% of patients get a treatment that has still side effects and that doesn't do anything. And as well, so the quality of life, of course, is diminished. And the second point is that, it's quite expensive. Immunotherapy is an expensive treatment, is around 100,000 euros per year per patient, and it's estimated it's going to reach 40,000 billion in 2026 only for Europe. So it's a huge economic burden for the healthcare system. So here at Ellogon, we try to use artificial intelligence then to help into this selection, because we have possibly better tools. We can use computers now that can help quantifying better these scores, such that this selection happens in a more efficient way.
That's great. So speaking about AI, what kind of AI or machine learning does Ellogon primarily use? I'm going to guess there's computer vision involved, since we're talking about slide sections.
That's right.
But more specifically, we're talking about YOLO and then object detection. Like, what are we talking about here?
Right. So before entering maybe into the details of the models, it's good to give to the audience, I would say, a bit of an idea of what kind of input we're dealing with. So in the next slide, you can see a sample, which is the same sample of that we're showing on the right side, which gives you a feeling of how big this actually image is. You can see that this is just a small sample of 6 by millimeters, kind of. And this leads to a 40,000 by 40,000 pixels. This is a gigapixel image. And if you zoom in, this is the kind of patterns that you start seeing. For normal people like me, it's very hard to kind of distinguish the different cells. But medical experts and ideally also our AI models can actually do it quite nicely. And so what we trying to do, as I said before, we try to get from these images a score. So from this image, we want to run our AI models such that, as you can see in the next slide, some areas can be classified and predicted, and then these areas can be calculated and fed to a simple ratio formula that then becomes a score, usually a percentage. So for instance, the dots on the red area, that's already like the ratio of black dots on the red area, that's already a possible score, for instance. And so coming back to your question, to do this kind of tasks, we well, we started with very popular models. As you mentioned, indeed, we used YOLO for detection, for sort of classifying, as well as findings these cells in the tissue, but also segmentation models. One of the earliest models were UNets. And obviously, these models have been heavily modified for the task at hand, but that's what we're talking about. Yes, that's what we're using. That's what we're using.
Great. And in terms of actually deploying these models and getting them out there, getting them to the market, and getting the hospitals to be able to use these, what kind of services is Ellogon using behind the scenes?
Yeah, so we opted for a microservice architecture, which runs on Kubernetes. The high-level components of this architecture is, well, an API component, which is for programmatic use of our service, then an object storage that is for storage of, well, the slides themselves and the results of our AI models, a messaging system for live events or internal queues, and a database, of course, for querying, filtering, and all these kind of tasks. And then finally, the most key component is a job queue, where we essentially enqueue our task of processing a slide. This role is right now fulfilled by UbiOps, which is doing it quite nicely because it's easy for us to it's just neatly integrated, easy to integrate, and we can scale our models from 0 to, as many resources as we can afford.
Great. So UbiOps is being used for the worker pool, and
Yes.
Are there any other services involved there as well?
No, in that sense, we just let UbiOps deal with. We just enqueue essentially from the services that you see on the right side. We take care of receiving a slide, pre-processing it, accepting it, and then we trigger a job, and then a worker from UbiOps will pick up the slide, download it, perform the processing, upload the results in the object storage, and this is how it works pretty much.
Right.
Yeah.
So we're getting kind of into the operations here, right? Of the machine learning, the MLOps machine learning operations. So different people kind of have different interpretations of that. What does MLOps mean to you, Leonardo?
So for us, MLOps is very, very important and is at the center of our quality management system. Our quality management system is very important for us because it defines the standard operating procedures we have to follow during our product development and maintenance. So for us, MLOps covers all those phases, such as data management, labeling, training, validation of AI models, their deployment, and serving.
Okay. So I always like to give a bit of a UbiOps perspective definition at this point. So for us, MLOps is it's a huge part of what we do at UbiOps, and basically it's the processes required to successfully take an AI or machine learning model to market. So everything from tooling to ensure availability, reliability, security of models, to orchestration, managing computing resources, data pipelines, etc. And oftentimes teams are going to be patching together these functionalities and sourcing their processing from multiple services. But at UbiOps, what we like to do is basically streamline the entire MLOps and AI infrastructure experience to go through like one single control plane. And it's compatible with cloud setups, in-house setups, hybrid setups, multi-clouds, you name it. We're gonna make it work for you. So with that said, let's move on to what's trendy right now in MedTech AI. So what would you say is trending right now, Leonardo? Are you able to escape generative AI in your niche, or is that not possible?
Well, generative AI in our domain is not yet utilized too much because we don't care too much about generating new data, although it might have some space, for instance, in generating synthetic data sets. That's very interesting. And we also had some thoughts on using it for sort of generating as well different stainings, starting from a specific initial staining, but this is a bit of a technical detail. But in general, I would say that it's very interesting for us using self-supervised learning as being very useful to extract relevant features from these whole slide images. We did some exploration in transformers architectures for instance, for gigapixel images, but still we found that the simplest models work the best because they're also easier to scale. They're very efficient, also computationally. And yeah, they're very effective in general.
Yeah. Right now, where do you actually see the potential for the biggest impact, whether that's social, economic, the biggest impact for AI in healthcare?
Definitely for personalized medicine, meaning that having treatment tailored to the patient. That's something that in some way we are doing, in the sense that we can have AI at some point that based on the features of the patient, we select the right treatment and that is tailored exactly to him or to her. And well, I would say then quality of life, for instance, in our specific case as well, remove the unnecessary suffering from side effects because we would get a more effective treatment. And well, the economic burden to the healthcare system as well. Those are the highest, top three, I would say.
Yeah, I mean some promising stuff there.
Yeah.
So in your area, what types of computer vision models have you found to be particularly useful or relevant?
Yeah, so as maybe I mentioned before, YOLO was great. We are using a modified version of YOLO 3 and with different backbones, different things happening, also to get together more context, but at least for detection and for segmentation as well, we found useful to tune a little bit these models for our tasks. But actually, yeah, I would say that this is what we're doing pretty much. This is what we're using. So
yeah, I think you mentioned UNet as well, right?
Yeah. UNet for segmentations, which for the people who doesn't know, who doesn't know, but segmentation is essentially classification pixel by pixel. So they can get these areas classified as a specific class type of tissue, for instance. Yeah.
Okay, so we've talked a bit about what's going on right now. What do you see coming as the next big thing? The next big AI trend in MedTech, whether that's specifically for immunotherapy or cancer diagnosis or more broadly?
Yeah, so what we're trying to do right now is to mimic humans in the sense that we are trying to not change the diagnostic workflow, but to augment it and sort of help humans give. So we are trying to get the same scores that human would come up to. But this is one way of doing things. Since now we can get data like which patients survived and got immunotherapy, now we could also reverse sort of the process and search for, instead of using these basic formulas of like a lot of lymphocytes near the tumor, we could say, or a lot of immune cells near a tumor, we could also ask ourselves or ask AI models to find new novel potential signals from these images that could help us even to get an even better prediction for the outcome of the patient. So essentially finding a way then from these images to search for new novel biomarkers. That I would say it's a very interesting concept. Then having large models that are for pan-cancer problems, so that are trained for different types of organs or different types of tasks. I think having maybe even open source, who knows, having this kind of models that can be used for each of these different tasks could probably be a great future future trend, then yeah, that's it, I would say.
Yeah, yeah. So how do you think these will impact your field? What kind of new healthcare benefits are these going to bring up for people?
I think it will impact cancer research because then humans don't have to think necessarily about things that they see, but they can also start thinking maybe at signals that are not entirely visible. Yeah, by just looking at these images. Some of these might be trash, of course, but some others might actually be have like a causal relation to the final outcome, and so that's something that usually researchers in this field look for, and so that's nice. And so, of course, this would lead to improved predictions in terms of patient outcome, whether he survives or not, and this will have again an impact on the clinical workflow, meaning again less expenses, better quality of life for patients, etc., etc.
Great, great. Well, thank you for your insights, Leonardo. Really appreciate that. I think it's time that we kind of zero in a bit on those scaling challenges. So, for you, what is the most important requirement that needs to be fulfilled for your models to be successful? For example, do they need ultra low latency? Are they need to be run in real time, or do they need to be really really secure? Do you have fluctuating demand? Like what's needed for you to be successful there?
We definitely don't need ultra low latency, but it also shouldn't take forever to process a slide. So I would say we need high throughput, meaning a slide should kind of be processed between minutes to hours, depending on the size of the image itself. So it should scale very well. Then our AI pipeline should scale well. Then we are definitely more into the fluctuating demand, which is also not very easy to get in the cloud. And UbiOps is great in this sense, as it optimizes the best GPU prices and availability also across multiple cloud vendors. That's also an option. And then obviously, since we're dealing with a medical device, security is paramount, and we are working towards ISO 27001, as well as NAN 7510, which is essentially the cybersecurity standard for the Netherlands. But at least for the component of the job queue, since we're using UbiOps, UbiOps is already certified in this too, so we already covered that, at least in that component.
Yep, you're welcome.
Yeah, thanks.
So can these kind of success factors, can these be achieved for a startup or SME without needing to be, basically a powerhouse like Google or AWS, without needing like a huge amount of funding?
That's definitely very hard, considering that the average startup doesn't have too many resources. So it's not impossible, very unlikely for a startup. There will be too high initial costs and also maintenance costs afterwards. And more after, also there is a problem in terms of hospitals have special requirements oftentimes in terms of infrastructure. So for us, it's important to be flexible, but this comes up obviously at a cost. So,
Right.
I would say.
Yeah. It's hard, but you can manage.
Yeah.
Yeah. So what kind of difficulties would you say a team can expect to face when they're scaling up?
One of the biggest challenges is to be able to process a large amount of slides, terabytes and terabytes every day, to satisfy our client requirements. Then, of course, prepare adapters for every different hospital, because every different hospital doesn't have yet a standard sort of IT system for patient management, image management. So for each one of them, we'll probably have to write some code, a glue code that will connect these things, our products and their system together. And in the end, I would say the integration in the actual clinical workflow, it's something that is a hard task, a big challenge. And to being able to enter into the production side of hospitals, it's something very hard.
Right. What have you found to be the most difficult scaling challenge if you had to name one or two?
I would say, well, from my perspective, so it's going to be mostly technical. I would say having automatic pipelines that help us automate those different components of MLOps. So, for instance, I don't know, data ingestion, labeling, model versioning, hyperparameter search. All these things are still kind of manual processes in our company for now because we need to grow in that sense. But then, so having a more streamlined MLOps system, that's definitely something that is a big challenge for us. The reason of that is that, well, the data that we are utilizing it's very special in some way. And we didn't find a solution that, at least for these parts of MLOps, a solution that fits our needs. For serving and deployment and serving, UbiOps is great. But for the other part is, we don't know yet how to solve this problem and to scale it up.
Right. And in addition to those technical challenges, did you have any organizational challenges that you had to face as well?
Well, this startup definitely has to deal with a complex problem, and this requires a lot of different knowledge from multiple disciplines, for instance, regulatory, medical, technical. So finding the right people that can communicate effectively, it was interesting. It is interesting, yes, I would say.
Great. Okay, we've got a bit of an overview of the challenges involved. Let's figure out how we can solve these. So, what strategy will you come up with to kind of tackle your scaling challenges?
So initially we had a bit of a homegrown solution, homegrown job queue. But after some time, we noticed that there is really too much to do. And so we moved to UbiOps because it was a simple way to abstract things, run them everywhere in a very flexible way, and with monitoring, traceability, all those very nice things that regulatory people really like. And that's how we solved the issue. This meant lower time to market, costs, and you name it.
Right. One big question that often comes up that I'd really like to get your perspective on is, how do you decide whether to build your own local infrastructure or go for one or multiple clouds? Or have some kind of hybrid solution? Like,
right.
How do you decide that?
So for us, it depends a bit on which part of the MLOps we're talking about. So for a startup in the initial phase, of course, there is no profit and training AI models is expensive. So for us, having a long-term and pay-once solution was essential. So we built our own on-premise infrastructure, which we used to train our own AI models. This was also a bit more forced into us in the sense that many of our data sources also required that did not allow us to move our data from our on-premise infrastructure to anywhere, not even whatever cloud, even if it was located, for instance, in the Netherlands, and no matter the certification. So this was also a big constraint for us. Then, so this was our decision in this regard. But for production, obviously, it is very hard for a startup or a medium-sized company to have the resources to scale enough and serve so much data. So in this case, well, the answer is kind of there is no other way but using these huge hyperscalers.
Right. I mean, scaling AI, it's not just about the compute. You also need to manage, retrain, update live models, update deployments that are increasingly active, monitor your performance, implement fail-safes. How have you addressed all of these steps?
So It's indeed complex, especially to address all these things all at the same time. So many of these things are still manual in the sense that we have scripts, we have things that can run automatically, but they're far from being optimal as an automatic pipeline. So our goal is first and foremost to build the best AI models. So we compromise this effort into building the best pipeline for MLOps to develop them based on the business priorities, obviously. So it's a bit of a compromise because obviously if we had an ideal MLOps pipeline that things would cycle, we would be iterating faster, but we don't have the resources to get there yet. So we are a bit stuck in there, but we're getting there. So for us, as I mentioned before, we need custom solutions for some of these steps. So that's an additional challenge. But thanks to UbiOps, some of these steps, such as increasing active deployments, monitoring performance, and failsafe are already nicely provided by the service itself. As for reliability, availability, also are great features that we use every day. Yeah.
Right. So how would you say UbiOps kind of specifically helped you resolve your own scaling challenge or part of it? Like which specific steps has UbiOps helped to resolve?
Right. So we had hospitals that had their own, they had as requirements to run our product on their own cloud infrastructure, so on a specific cloud provider. Other that said, oh, you have to run it into our on-premise infrastructure. So UbiOps is great for this because it provides great flexibility, both for on-premise, cloud, or hybrid. So that was, I would say, a great feature. But it's cloud agnostic, which is, again, connects to the fact that some hospitals have special agreements with some cloud vendors, and hence, UbiOps is flexible again also in that regard. And then the pricing schemes are also quite nice compared to just using barebone, Google, AWS, or Azure, because you can get the best GPU pricing across multiple cloud vendors. Finally, it's easy to scale things in general. In UbiOps, you have a nice pane and a nice dashboard in which you can clearly see and change things the way you like, and tune them also depending on, for instance, in our case, to the model size in our pipeline. And so you can scale more, some models that are maybe big and require more time. You can make more instances. So all these things are great.
Great. So a lot of different features there. If you had to kind of focus on just one or two, what would be your kind of most useful features of UbiOps that you use?
Yeah, as you can see in the slide, this is a feature that we use a lot because it really helps us abstracting our main sort of abstraction, which is an AI pipeline, which essentially gets a slide and generates a report. And what you see in the middle are all the different AI models that we can scale independently. And so, this is a template of what we use to run our AI pipelines. And this has been very, very useful for us.
Awesome. That's great. I think I'll give a little bit of background on a few more of those features that you mentioned, just to kind of put them into context. So UbiOps as a platform can be used through our web app, through an IDE, through a terminal. We have an extensive API library, so users can access any of our functionalities from wherever they prefer to work. So implementing UbiOps doesn't need to be a huge kind of, organizational turnover. So UbiOps as a platform can be used as a cloud solution that will source processing for your applications on demand, or it can also serve as a control plane between your AI and your compute, whether that's on-premise, in the cloud, or a mixture of the two. And as Leonardo mentioned, pipelines is one of our most popular features, and it allows you to chain together multiple deployments and other objects like data transformations, or even sub pipelines, to standardize your workflows and make things a lot more repeatable and simple in the future. They're really a great way to optimize your use of computing resources. They can even reduce your costs because you can have this really granular control over when you're using what kind of processing. So it helps you work in a more manageable, modular way. So, Leonardo, I actually have one last question for you to kind of sum it all up. If you had to give one piece of advice to a MedTech team out there that's looking to deploy a machine learning model, what would that be?
I would say to start simple and plan for incremental changes. Start with simple models and then try to scale them, and then just have this incrementality, right? So that if you have more resources, then you can always do better in the future, but don't start too big. Otherwise, you might not be able to ever finish your product. And the second thing is to not underestimate, at least in the MedTech world, the amount of work required for regulatory compliance. So the sooner the better you start working on these things, the easier it's going to be the life of your business, probably.
Great advice. Thank you very much, Leonardo. So before we move on to the Q&A, just want to say again, thank you so much for joining me. It's been a real pleasure speaking with you. I think we all learned a lot.
Likewise, I hope. Nice.
So I can see a couple of questions have been coming in the chat. I've been trying to keep an eye on that. So I think it's about time we kind of open the floor for that. So for the Q&A, we're also going to have my colleague Shubham, who's going to join us. Shubham is a solution consultant at UbiOps and actually has a few questions of his own. So if you haven't already, feel free to write down any questions in the chat, and we'll pick them up. And if we don't get a chance to answer any of your questions, don't worry. We'll let you know, and we'll get you the answer you need via email. Alrighty. So I see a question in the chat here. So hospital-specific implementations, can be a bit of a generic challenge that a lot of startups face. Leonardo, do you see avenues to collaborate with other service providers out there?
Yes, in the sense that we saw already that there has been some work, at least here in the European station, sort of standardizing a bit more, or the amount of services that are using in hospitals is getting reduced to a few, or in the sense that they're offering most of the internal services. So that is of great help, obviously, because it helps. I wouldn't say that there is a standard yet. If there was actually a company that would take care of standardizing and making a uniform layer between all the hospitals, that would be great. It's hard for me to see that happening because hospitals are so independent between each other. It seems to me that it should come from the politics in some way. Yeah.
Right. I see.
I'm not sure if I answered your question, but in case, just let me know.
Can you, we have another one here. Can you comment on the productivity gain that's achieved through using Ellogon versus manually generating biomarker reports in hospitals?
This is actually a big problem in hospitals because it's very tolling for the medical experts, which in this specific case are pathologists. They are highly trained medical experts. And for them, looking at a slide for 1 hour, they have to look at it for 1 hour, or they usually do that, and come up with a score. They get, their eyes red, and they have to do other 100 slides to finish. And they have obviously to come up with scores that are, that are as reliable as possible, right? Because they will end up deciding for the treatment of a patient. They will not be the only deciding factor, but they will get a big factor. They're a big factor, obviously, in that decision. So that's probably, sometimes hospital cannot even process the amount of patients that they have. So I think per day we can process easily in a bunch of hours, thousands of slides. And this is what the current, that's the current load that they have to face between multiple, of course, histopathologists.
Great. Thanks. Thanks for that answer. I have another question here from GG. Knowing you moved from on-prem to cloud infrastructure for operations simplification, and knowing cloud resources are elastic, do you have a challenge in controlling cloud costs related to iterative trainings, hyperparameters, search, other activities? And if so, how do you solve it?
Right. So in this sense, for hyperparameter search, because this is a problem. So we didn't move from our on-premise. So for training, we are still stuck on-premise because we cannot move our data, our training data outside of our on-premise infrastructure. Only few data sets which are public are used or can be used. So those, of course, we can run pipelines on the cloud, and run trainings there, but we cannot incorporate anything else. Most of our data comes from sources which protect this data because it's actual patient data and it's protected. And we cannot move it from our on-premise infrastructure.
Okay.
So I have no experience into controlling cloud costs specifically for training and hyperparameter search. But we would love to get there, but we have to find a way first to move the data there in a way that is okay for the agreements that we have with our data sources.
Right. I have another one here from Bart. Could Ellogon open up broad molecular diagnostics to peripheral hospitals that don't have access to highly specialized staff?
So I'm not sure about molecular diagnostic, but about the second part, so maybe. So it depends a bit on the task because I'm not sure I understand exactly what is broad molecular diagnostics in this sense. So I'm sorry for that. But if you could help me a bit understanding better what do you mean by that, I'd love to give you a more elaborate answer.
Yeah, I can see Bart is typing there. Let's get to Gigi's question in the meantime. Can you also tell us more about regulatory constraints that you're facing and how they impact your solution?
Well, it means that everything that we write, that we build as code and all the how it's gonna be used from the user perspective in terms of security needs to go through a risk assessment. So we need to define all the risks that are associated, all the countermeasures that we are making, and finally, this needs to be transformed into requirements, into a specification, and the points of the specification needs to be met, ideally with a test for acceptance. And so this is how I would say is impacting it, meaning that it's obviously, rightfully, I would say, slowing the development process a lot, but it's for the right reasons, right? It's because we don't want to put out there a medical device that is unreliable. Although we don't make a final decision for a treatment, even just aiding someone into, biasing them right into making the right decision is still a very important task that shouldn't go wrong. That's it for me.
Great. I think you got a little thumbs up of approval there. I have the follow-up from Bart. So he's asking about the broad molecular diagnostics. So broad molecular diagnostics links targeted therapies to specific tumor targets, but involves knowing a lot about the specific target bindings. It's a task that could potentially be solved using technology.
Yeah. So, okay, this is interesting. I'm not a medical expert in this field. I'm more on the technical side, but if I understand correctly, it's a bit like sort of we are trying, one of our biomarkers is, for instance, understanding how much is a tumor cell actually, how strong is the mutation in the cancer cells. And we are trying, for instance, to predict that by just looking at these images, right, without running any DNA sequencing. So maybe we could, in theory, try to get more of these features of these cancer cell features, so of the proteins around them. But obviously, these proteins are too small, right, to be seen even from this resolution. But there might be some signals that, some of these targets you're mentioning, diagnostic targeted therapies, target bindings. I'm not sure if this is what you're referring to. There might be something there, right? But all of this is very, it requires a lot of research, I would say, and that's definitely something that we are eager to actually get involved into. But it's not for now. We are focusing on our products and scaling up. So maybe in the future.
Great. Well, looking forward to seeing that in the future. I have another one here from Shubham. How do you handle errors in AI algorithms? For example, false positive errors and the predictions, or like in other words, what is the sort of accuracy of your solution?
So it depends on the biomarker. I would say we can reach. It depends on a bit on the biomarker and what is your task. We can reach, depending on the specific task. For instance, for segmentations, we can reach 80%, 90% dye scores, as well as for classification of lymphocytes, we have very low false positives. All of these metrics are recorded for every AI model that we have, and they are usually all above 80%. But the most important thing is our correlation to the patient outcome, meaning that all the scores that we try to predict, our actual test, if the product works, is to see if these scores are predictive for the final outcome. So that's by using simple correlations. So we want to see if we put a threshold on, for instance, the SGLS biomarker, which is essentially how many lymphocytes or immune cells are attacking cancer. We want to see, let's say, if it's above 30%, let's say that the value is 40%, this is above 30%. We want to see if our models predict 40%. Does it actually mean that the patient will survive more than 5 years? So this is in what we actually benchmark our algorithms, because that's what it's important in the end.
Great. Thank you very much for that comprehensive answer. I have another one here. Can you comment on data privacy or security when one hospital is using Ellogon?
On data privacy security when one hospital uses Ellogon. Well, it depends a bit on the hospital, because it depends also if it's an hospital that it's okay in terms of moving data in a cloud environment. Then security is obviously provided by standard protocols like HTTPS and encryption at rest, and the highest standards, obviously, that we can provide. If it's instead inside the on-premise infrastructure of the hospital itself, then that depends a lot on the hospital security measures, because that's considered sort of a safe zone. It's still segregated compared, because obviously multiple services are running. So it's not that we stop having our highest security standards, but they are, it's just it works a little bit different. It's a bit of a safer place than going out in the cloud.
Right. And I think you mentioned previously that when you do work with hospitals like that, in terms of running models, you're also able to actually install UbiOps more locally so that they can kind of run their models in-house, and they don't have to worry about data traveling outside of their infrastructure.
Precisely. Yeah, indeed.
Yeah. I have a question here from Ono. If your training data could be anonymized, would you then move your training jobs to UbiOps, and why?
This is something that we actually are considering. Why is because, again, of scalability and pricing reasons. It's very nice. Also, we would have the same platform in which we run trainings and then deployment of the models. So that's also, I would say, simplifies a lot the management of this service. But then also, if the data could be anonymized, so yes, in general, we would do that probably.
Great. Again, looking forward to that as well. I can see Zoran is typing. I will ask another question in the meantime. What do hospitals need to do if they want to experiment with your solution?
Right. Well, they can contact us. Just send us an email, and we can provide a demo environment for you, such that you can try to use it and have a feeling of how our product works. And then, we can start from there.
Great. And how much time does it typically take to implement Ellogon's solution?
That depends on what kind of requirements a hospital has, in the sense that if Ellogon, if they're okay into sending data into the cloud, then nothing, in the sense that they can just log in with some credentials that we can give them, start uploading slides, and get results. If you need integrations, that might take a bit more time, depending if we have already these glue code and adapters that can interface with the hospital patient management system or image system.
Great, thank you. And I think I have one last question from Zoran. How do you solve upload of inference data at scale? What protocols and results saving or return? I'm not sure I understand the final part.
Inference data at scale. All right. So I guess the question is about how do we store our data in our storage systems. Usually what we do is storing these segmentation masks and detections in different ways. The upload itself is not too bad, because actually, while the images are extremely big in size in terms of like memory consumption, the actual results are consume way less space in that sense. They are, I would say, for an image on average is around 15, 20 megabytes actually, because we store the segmentations in 1-bit masks. So things can be compressed quite a lot. And
Great. Well, I think we're going to need to wrap up the session there. We're approaching the end here.
Right.
But first of all, I want to say thank you so much again, Leonardo, for joining me today and for sharing your insights on AI scaling challenges in MedTech and more and sharing more about Ellogon. So thank you again.
Thanks to you, Yvan, for having me.
And of course, thank you everyone for joining us and making this session so awesome. I'm really buzzing for our next live session, which should be about a month from now. So we'll keep you posted about that on our LinkedIn and our weekly newsletter. So make sure you subscribe to those for updates. You can find links in the session description or on our website. UbiOps.com. We're also going to be posting a recording of today's chat on our YouTube channel. So if you want to get updates on that, then go ahead and subscribe to our YouTube channel. For those of you with unanswered questions, you can join our Slack community. Check out our website for the link, UbiOps.com. And if you ask any questions there, one of our community members will definitely help you out. As a parting note, if you felt like any of the challenges that Leonardo Romor brought up applied to you and your team, remember you can always reach out to us for more info or guidance, or check out our website. We're always here to help. Once again, I'm Yvan Fafchamps from UbiOps. Thanks again for joining us. We'll see you next time.
Bye.